Good evening, students. I'll start with the class. Today we'll start the new chapter, that is mechanical properties of solids. Just a small chapter of 3 marks. So under this chapter, we will see what happens when we apply some force on some solids. So we have noticed any solid, whenever you try to apply some force to a certain extent, there will be some change which will be occurring in the body. Okay. So it depends on what kind of force has been applied. If you try to put only one side force, the body might move ahead. But if you are trying, if there's a body, consider a ball, you are trying to apply a force. So this is an unbalanced force. There is no balancing force which is there on the side. So it will move forward. That means it will accelerate. But suppose if you are putting force from both the sides on this ball, what is going to happen? It will not try to move. So basically, the ball will slightly go inside. There will be deformation. Slightly it will get compressed. And then when you remove the force, it will come back in its original position. So basically, when we apply some force, there will be some kind of change in the body that is called as a deformation. It's deformed. So, right, what is deformation? The force is applied to a body can produce a change in the shape or size of the body. Either the shape will change, size will change, or both might change, shape as well as size. Such change is called deformation. So, what is a deformation force then? The force which causes the body to change its shape is called as the deformation force. Deformation force. The force which produces deformation in the body is called deformation force. Now, based on this deformation, there are two types of deformations which can happen. One is the elastic one. Don't write this, that gives later. One is elastic and the other one is plastic. Okay, under elastic, what happens is, consider a rubber band. So you know that when you stretch the rubber band, that is what when you're applying force. So the force causes deformation in the rubber band. It will get stretched. So its original shape will change. Now when you leave the force, the rubber band will come back to its original position. So that is called as a elastic nature. So what is you'll have a word definition what is called as elasticity that I will give you. Elasticity will be what? The property of a body by which suppose it goes under some deformation, then when you remove the external force, it regains its original state. Means what? It will come back to its original state and it will be called as elasticity. It's the property of the material to come back to its original size. But under plastic, what will happen is plasticity, the moment you stretch it, okay, anything or it like if it has a plastic nature, it will not come back to its original position. It will either break or it will get deformed permanently. Consider your pencil only. So if you try to bend a pencil or apply a larger force, the pencil will break. It will not come back to its original position when you leave your force. So that is called as a plasticity. Plasticity is what? When it gets deformed, what will happen? It will not regain its original position or original shape and size. Then you will have something called as, okay, I'll show you the difference, what happens under. So why does this happen? So any material, suppose if you have any material, it will have some bond between them. So what happens for elastic material and what happens for a plastic material, I will tell. So whenever in elastic material, when you try to stretch, I'll show you an image. It is starting one is the first top three are for elastic deformation. Every material will have bonds inside it. So they have just zoomed it in the circle. So look into the circle. So now consider for the rubber band. Inside there are some molecules. So look at stage one, initial stage. So these are the bonds which are connected, interconnected. Now you're applying some small load. Small load means you're applying some force. So if you're applying some force, you are basically stretching the rubber band, suppose. So see what will happen. The bonds will stretch. Okay. But they are not breaking. The bonds are not breaking as such. They are still there. They are just getting stretched in a regular pattern. And when you remove, unload means what? When you remove the force, they will come back to the same position as before. That is for elastic. But now you see for plastic, same thing. But now what is happening? They are not following a proper pattern. Okay, the bonds will stretch. Okay, that word shear and all, I'll explain to you later on. There's something called as shear stress and all. They'll go in slanting of whichever position they want. So it will not be a uniform one. The bonds, whatever, will get stretched in a non-uniform way, and then the bonds might even break. So when they come back to its original try to come back, they might not get back to its original position. See, see the initial and final stage of elastic and see the initial and final stage of plastic. It might get slightly try to come back from, see, the third stage is slightly smaller compared to second, but not same as first. Why? Because the bonds will not come back to its original position because they have been stretched ununiformly or non-uniform. So this is what happens under elastic and plastic materials. So under elastic, they stretch in a nice proper way so they can come back. But in plastic, the bonds will get stretched anyhow, okay, and then they suffer some damage, so they are not able to come back to its original position. So why are they, see those bonds, you see, once they got stretched, they have to come back to its original position. Now when you leave the force, how are they able to come back to its original position is because of something called as a restoring force. We have seen that under spring also, same thing works for spring. You have a spring, you stretch it, so you are applying external force and you're stretching it. But when you leave this force, who is bringing it back? You are not putting reverse force on it for it to come back, but it is automatically on its own coming back. So it's something called as a restoring force which is there inside it, which tries to bring it back to its original position. You are not putting reverse force to make it its own force. This restoring force, same way it is inside this also material. So whenever the bonds get stretched, the restoring force should be strong enough to bring them back to the original position. They are also called as what? Internal restoring molecular force. Those terms I will give it to you. So this is the basic difference. Now there's something called as a elastic limit also word. Now any material is elastic doesn't mean you can keep on stretching it and at some point you can take it to some 1 kilometer and it will come back. Consider your rubber band itself. Okay, you might try to pull up to a certain limit or certain extent. So the rubber band will get stretched. If you leave it will come back. But if you keep on stretching it beyond its certain limit, obviously the rubber band will break. Okay. Same way, consider your ruler. Even certain, they say, is plastic, no? They will have certain elasticity to a certain point. And beyond that, then it will break. But it might be a small one. Consider your ruler only. If you try to bend it slightly, it may get slightly bent. Okay, a ruler may slightly get bent, and then if you leave the force, it will come back to its original place. But if you try to bend it too much, the ruler will break. So certain plastics, they have elasticity to a small limit. So the limit depends on how much material elastic is. It can vary from different materials. Rubber band will have definitely a lot of limit. But if you have a wooden stick, the wooden stick elastic limit will be very less. The different material will have different elastic limit. So I'll give you what is elasticity first. Elasticity is the property of a body by virtue of which it may suffer deformation in size or shape under action of external deforming forces. But regains means it comes back to its original position. Regains its original state on the removal of external forces. Let's read it again. Elasticity is a property of a body. Body means any material by virtue of which what happens, it will suffer. Means what? It will have an effect. It will suffer deformation. It will get deformed in shape or size. If you forget these words, at least say like this: the body may undergo deformation in size or shape under the action of some external deforming forces. But what happens? It will come back to its original state on the removal of external deforming forces. So remember that whenever you are applying external forces, it will undergo deformation, but when you remove it, it will regain its original state. So that is elasticity. So there are certain materials which have elasticity, like steel, copper, bronze. Next is what is plasticity. Plasticity is a property of body. You can, instead of saying by virtue and all, you can use this word, due to which it gets deformed. Easily, even a small, under a very, under a small deforming force, and has no tendency to regain. No tendency means it doesn't have the capacity to get back into its original shape. When the deforming forces are removed. Example you can give of cement. So you have seen whenever you have a cement, you have a heap of cement, and you put a spoon on that, or whatever this worker put, laborer puts, then it will change. The moment it hardens or whatever, you cannot get back its original shape. So it will change its shape, and when you try to leave this external force, it will not come back to its original shape. Now the next term is elastic limit. The maximum stress, we'll learn this word, what is that stress, to, a, to which a body can be subjected without deformation. You can think of that rubber band I told you. The maximum force or the maximum stress which you can, to which a body can be subjected. How much force it can be applied till a point without any deformation. Means what? I can remember that the rubber band should not break without permanent deformation. This is very important. It will get deformed only, but without permanent. This word is important. Because when you stretch a rubber band, definitely there will be deformation. But the deformation should not be permanent one. It should come back to its shape. So what happens actually under this is, if the stress applied body is within elastic limit.
Miss, this is the second point.
Yeah. Just this is a basic definition. So just to understand what exactly happens to stay in the elastic limit with respect to the molecules which I had explained, no? So that part I'm giving.
Okay, Miss.
If stress is applied to our body is within the elastic limit, so what happens is the distances between neighboring atoms or molecules, you can say neighboring atoms are changed and internal restoring forces are set up. The moment you stretch, what will happen? I told you. So these molecules will get, so there will be some internal restoring forces which will start developing between the two atoms. If there were no forces which were pulling them, they would break. These bonds would break and then the material would get deformed. The internal restoring forces are set up within the body. These forces help the body to get original shape when to restore, you can say the word. To restore, you can say word. Restore its original shape when external forces are removed. Now what happens if you, one second, let me, okay. Now what happens the moment you cross elastic limit, what happens to the body? That will be like another point I'll give. Now this point is when the stress applied is within the elastic limit, the distance between the neighboring atoms are changed. And then internal restoring forces are set up. So these forces will help the body to restore its original shape and the external forces are removed. Now, if the stress applied is beyond, means more than the limit, beyond the elastic limit, the molecular structure of the body is disturbed. Okay. Therefore, deformation is not fully recoverable. You cannot bring back it fully to its original shape. It may be half recoverable, as I showed you. A little bit it might try to come back, but not fully as how it was in the original. Let's just give you what is the difference, point of differences between elastic and plastic force. The elastic bodies regain their original shape after removing external deforming forces. Here it is do not regain. Or do not regain their original same. Second one, deformation is reversible. You can reverse it. Whatever deform means not permanent. whatever deformation is there, you can reverse it and get back to its shape. But here it is irreversible. That is permanent. Here what happens? Restoring internal molecular forces are large. Restoring forces, huh? Just use the word restoring. Here, internal restoring, same thing, molecular forces are extremely weak. That's why they don't try to bring back. Are extremely weak. They are strong enough here forces, so they pull back the molecules. There they are weak, so that's why the bonds will break. So this is the difference between elastic and plastic bodies. Now we had seen what is this word stress. So we'll study that in detail now. So what is this stress? We have seen before, we have already come across of this example also. Suppose if you have a sponge, so you try to apply some force, suppose. Now what will happen? Whatever might be, there will be some deformation, or the sponge will reduce, okay, will get compressed. So now what is stress is nothing but how much of force you had applied on this particular area. So stress is nothing but the force once applied, it should be able to cause some change. Only then it will be stress. Okay. If your force is able to deform the object, so by how much it is getting deformed also, so based on that also it depends. So how much force is applied on how much area. So it gives you the definition of stress. Formula wise, it is nothing but stress is force upon area. So basically it is nothing but it works for this also. How much of restoring force developed, because it is how much ever force you are putting, equal and opposite restoring force is needed to come back to its original shape. So it can be restoring force upon area, or it can be same as external force, because this and restoring force is same. Only thing it will be opposite in sign. But if we just want to calculate the magnitude of stress, then it works for restoring force also and for normal external force also. So basically it's force upon area. So this is a formula for stress. Stress, in terms of definition, stress is defined as measure of internal restoring force set up per unit area of deformed body which tends to bring the body back in its original state. Or the restoring force per unit area of a deformed body. You can study this, the restoring force per unit area of a deformed body. So we'll see what is the unit of stress. We know that stress is force upon area, so that will be Newton. Area formula is meter. This unit is meter square. Basically, it is Newton per meter square or n m raised to minus 2. Because unit of force is Newton, unit of area is meter square. So as per the dimensional formula, this is the basic definition of stress, force upon area. Now, based on what kind of area we are using or what area is changing, there are three types of stress. It's called stress only. First one is tensile or longitude volume or bulk stress. Third one is just stress. These are the three types of stress. Or called as tangential stress. Okay. So first we'll see the tensile. So the word longitudinal means length. Sorry. Suppose if a rod is there, circular rod, which is fixed, and its original length is suppose L. Now, suppose if there is a force which has been applied and you're pulling the rod, so what is going to happen? Because of some force, or if you put some load over here, so that there will be extension in the rod. So from the original one, suppose if there's an extension, so that will be called as delta L, or we'll name it as small l. This is capital. This will be the area. And why is it getting stretched? Because there's some force applied. Now what is called as tensile stress? Tensile is just for because there's a long this. The tensile stress is nothing but restoring, basic definition. Stress is nothing but restoring force upon area. So here it will be what now? Cross-sectional area. This, not a whole volume, only the outer area of the circle, not the area of this rod, only the cross-sectional area. Here it will be pi r square. Then second one is, so if you want to explain, it's nothing but if forces act normally. Normal means straight, perpendicular to the surface. Normally along the length. Metal wire, or also called rod, etc. So as to stretch it. Just normal stress developed is called tensile or longitudinal stress. Normal means this, like 90 degree to the surface. So that's why the word normal is used, means perpendicular line.
Means how did
Yeah.
pi came? Pi r square.
Area of the circle. This will
Okay, miss.
rod, no, it is. So it will be area of the rod, cross sectional area of the rod. So this will be definitely circle. So if this is the pen, suppose, I'm not calculating area of the whole pen. This only the top part, the circle part. So that is called as the cross section. And this is called as the total surface area. That we are not bothered. Only the outer this part, because the force has been applied on the area and then it has been pulled.
Okay, miss.
So the forces are acting normally, means perpendicular like this along the length of the metal or rod, whichever it may be, etc. So as to stretch it, so it will get stretched, and the normal stress means this, what is this extension developed, is called as the tensile or longitudinal stress. Then the second one is volume or bulk stress. This was acting lengthwise. Now looking at the word volume, you know that it will act on the whole volume. Volume, not only this area, but of the whole volume of the object. So it's like considering a circle, suppose, means you have a bigger circle and you're applying forces on all the directions. So what is going to happen? This entire wall will get compressed to a new shape here. It will go inside. It's of course, this will be the change in the volume. Original volume means the entire what is filled up, and this outer part would be volume means everything, like this, and this outer area is called as the surface area. See, if you have a football, whatever air is filled inside the circle is the volume, but the outer area what you can see is called as the surface area. Even if you keep this, imagine a cup of tea. So the outer cup, what you're holding, that will be calculating your surface area. But if you fill up that cup with water, so the water which is inside is nothing but the volume. So it's the space which is provided. And area is nothing but a flat surface, like outer area. And this is volume. So the original volume is a big circle, full, entire. And smaller means this part, this volume. So bulk stress would be then forces. I'll directly give you the definition. So what happens when you apply a force, its volume will change. So volume stress equals to restoring force upon your area. So it is nothing but it is the restoring force developed per unit area of the body when the volume of the body changes. Deforming force acts on it. So what happens whenever the force is external, this force is applied, there is a change in the volume. So how much force is applied per that area, outer area, that is your stress. Which so this force applied on the area makes the whatever the body shrink, means change in the volume. Next, the third one. Third one is called as a shear stress. Or tangential stress. Let's show you the diagram first. Suppose if you have a box and your this face is fixed. Okay, the one of the face of the box is fixed to the surface. That will not move. That face cannot move. But now you are applying some force. If you are applying some force on this, pushing this, what will happen? Only the top part will try to move. This face will remain fixed only. By how much? Certain angle it will change. So we have this A, B, C, and D. And this is the new D. Force is applied in this particular direction. So there's a change in the dimension, and there's a change in length, and there's change in this particular angle, delta L. Same as this, no? Delta L. When you're deforming, force acts tangentially over an area. Then body gets sheared. Sheared means what? Keeping one of this. So it's like you are standing at one place only, you are not moving your feet. Somebody is trying to push you, only your upper body is bending. Okay, so it's called as a shear. When the body gets Shear means kind of bent through a certain angle. Such stress is called shear stress. Formula remains the same. Your stress will be force upon area. You can write it as restoring force also, no problem. Of force upon area. Stress, it is simple. Force upon area. Now we will be wondering where is that all required? That delta IL on all. Basically, we are just calculating force upon area. That theta and all is not at all into UC. But that is useful in calculating now the next term which we'll be learning, that is called as a strain. Any stress will cause some particular strain. Means what? Strain is nothing but a change in dimension. Stress is basically force. How much you are applying force, how much stress you are giving to the body. Now, how much change it makes, that word is called strain. So the next term is strain. Same way how we had three types of stress, same definitely will have three types of strain. So what is strain? It is defined as change in dimension of the body per unit original dimension. Strain is nothing but change in the dimension upon your original dimension. Per unit means upon. So basically, if you remember, you can write this. Same way, types of strain. Write all the three. Just instead of stress, use the word strain. Strain is tensile or longitudinal, volume or bulk. And the third one is shear or tangential. So first one, also called as linear also, if you want you can write. Linear means lengthwise. So what is longitudinal strain? When the deforming force produces a change in the length. So when the length changes, it is called longitude. Okay. That same thing it is. No need to write. The strength is called longitudinal strain. When the deforming force produces a change in the length, it is called as a one can write. It is called as whatever the same, or you can say it is the ratio within elastic limit. Everything what we are calculating now is within elastic limit. We cannot sit and calculate. Means already if this is permanently damaged and deformed, then there's no point calculating. So within the elastic limit, because it has to have a restoring force which would make it come back. When there's no restoring force only, when the body is permanently damaged or deformed, there'll be no restoring force. So there'll be no proper stress. And then you cannot calculate strength. So that should be within the elastic limit. The longitudinal strain which is L1 is the new length. New length will be more, no? It will be bigger. If you're having a small rod and you're stretching it, it will increase. So this you'll have to take first, bigger one. New length minus the original length. So it's nothing but for long. I did not write in terms of definition. You can write in change in length. Same it is. Instead of dimension, no, you have to just use the word length. Originally. Longitudinal strain is change in length upon original length. Same thing. Now it's simple. Same works for volume. So we have to just use the word volume then I think. It is strain, no? Change in volume it will. So if you study one thing, same thing you have to repeat. Here it will be volume. Based on the requirement, later we will change. Now we don't know whether it is shrinking or whether it is expanding. Whatever the volume, after applying ulta force, no, it can increase also. So we don't know which is greater. So based on the later when we are solving the problem, we will see accordingly which to minus. But as per formula wise, it is nu minus the original. Same thing you can write, just put a short listen kit, write same as this one, and only this main thing you can write a formula.
Plus, instead of L1 and L, we have to write
Ah,
V1
yeah,
and
yeah,
V2.
yeah, 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 yeah. Yeah, V1 and V2. And the third one will be 0 tangential 3. Now here slightly we have to, because now we have to explain this third one. Just one word we have to add. Just erase, because we have to keep one of the face fixed. That is the condition. The same diagram, let theta. This will be our theta. This is fixed. If the deforming forces produce a change in the now the shape is changing of the body with a fixed plane. This is a fixed plane. Plane means it's like the face of the page. It was a block, no? This space would have been, now I've drawn a two-dimensional one. But if we were actually looking, that this space would have been like a same, like a box kept on the floor. The face means a plane, not a line. Or you can say it is the ratio. It is called, this is a, it is called here, right? Or it is the ratio of the relative displacement of one plane to its distance from a fixed plane within elastic limit. Why it is called a word relative displacement? The whole block is not moving. Only a part of the block is moving. So that's why the word relative will come. One of the plane. Only the one plane means one face. And the other plane is one face is moving, displacing, and the other face is fixed. So there's a relative means this compared to this fellow, one face is getting displaced to its distance, to some distance from a fixed plane. So compared to this fellow is moving to a distance. Fixed point compared from a fixed point, how much it is moving. There's nothing but delta L upon L, but which is same as if you see a perpendicular one, it's nothing but tan theta. It is same as, which is also equals to tan theta. You can write like this. So strain, your strain formula is what? Either in terms of angle, if you know, then you have to use this formula. In terms of length, you know how much it has got displayed, then you have to use this. Next, there's something called as Hooke's law. Now you know that definitely stress and strain are related to each other. When can stress occur? Only when there's a strain. Of basically when you're applying force, there will be a change in length, or the river, how much of change can happen is based on how much stress you're applying. So it states that within elastic limit, the stress is proportional to strain. Depends on how much it is ready to move, no? That much extra force also you can apply. Okay. So if it's a length, till what extent it can get stretched, till then you can keep pulling it. So as the it's strain, the delta L, how much ever it is increasing, your force will basically you can increase, keep on increasing till a maximum point within the elastic limit. So it states that the stress is directly proportional to this. So if this increases, the force is also increasing. If your delta L is very small, then basically force is also small. Now, Whenever we remove proportionality sign, we write equal, then we put some constant. Whenever we remove the proportionality sign and we put equal, we always replace it by some constant. Now this constant over here is nothing but called as modulus of elasticity. The word for this constant is modulus of elasticity. How much depends on how much elastic that body is. Based on that only how it can get stretched. It varies for different materials. It will have same unit. This I'll just define. So basically just put here what is modulus of elasticity. The stress, strain I'll bring down. So what remains is the constant. Constant is nothing but I said modulus of elasticity. So stress upon strain is nothing but modulus of elasticity. So if you are asked to define what is modulus of elasticity, it is nothing but the ratio of stress to the strain within elastic limit. So, right? Stress to strain caused in the body within elastic limit. So this is definition of elasticity. If you remember this formula, modulus is nothing but stress upon strain. It's the same thing. Defined as the ratio of stress to the strain caused in the body within elastic limit. Now types of modulus of elasticity. You must have heard of this word Young's modulus. The type first one is the Young's modulus. Indicated by the letter Y. Young's modulus, so Y. It's nothing but, stress and strain is related to some kind of, there are three types of stress and strain we saw. One is the longitudinal, one is the volume, and one is the, a shear one. So whenever we are calculating stress and strain for a longitudinal one, the constant if we are using the modulus, that word is used for the length one is Young's modulus. So this is basically related to the length one, the first one. That is defined. First we'll write this way, Young's modulus is nothing but, it is stress upon strain now. What is modulus? In general, stress upon strain. Now the only word we are using will be, because it is related to the length, it will be longitudinal stress or tensile stress, okay, both ways. Stress upon strain. The only extra word is longitude. In general, it is called Young's modulus. This modulus, not related to length, it is called Young's modulus, or also tensile. So from this, you know how to define. It is defined as the ratio of longitudinal stress to the longitudinal strain. I'll just use a shortcut word, longitudinal, within elastic limit. Just you have to add longitudinal and longitudinal. So it becomes Young's modulus. So we'll just derive the formula for it, final one. So consider wire of length L. Then consider small l. We have used, so I'll use the same letter. Wire of length L and radius R. Thus, you can put a support here, suspended from a rigid support. Rigid means a fixed support. Now what is happening? They are attaching some kind of block to it, and then it will get stretched. If mass M is attached to the free end of the wire, there will be force acting on the wire, because obviously this block, when you try, this is of mass M, if you attach it to the wire, definitely there will be a force which will be applied on the wire. It will try to pull it. So there will be a force on the wire which causes, which results, you can say, increase in length of the, this you can extract in your own words. So block of mass M is attached to the wire, so there will be some force acting on the wire, so it will get pulled and it will increase by length. Okay, so how much is the force acting? So whenever you are having any block, we have seen that what is the force acting because of gravity is always M into G. Force acting is mg, that is F. Change in length L1 minus L. Okay, so according to the definition, what is Young's modulus? longitudinal stress upon longitudinal strain. Mark this as 1. So let us calculate what is longitudinal stress. We know what is the formula of stress, force upon area. So force is nothing but mg, and area of us, this is your area, which is pi r square. So mark this as 2. Just 2 more steps left and then wind up. Now same way we'll calculate what is strain. The longitudinal strain is change in length or increase in length upon the original length. Mark this as equation 3. So what you do? Put 2 and 3 in equation 1. Put whatever is the stress here and whatever is the strain put here. So why? Now the stress upon strain. So stress, how much you got? Mg, and strain is so this will reverse. So that's the formula for Young's model. MgL unit of Young's modulus is same as that of the stress. Unit is same as that of stress. Because strain is unitless. You want to know what is unit of strain? Under strain you want to write? It is dimensionless. We have seen that. No dimension. Or no. And unit of modulus, so it will be same as that of stress, that is Newton per meter square. Okay. So I'll stop here. Next class, there are problems based on this. You have to calculate stress, Then another only one more modulus is there, that is the bulk modulus. That is for the volume. That I'll do in the next class and solve some problems. Stop here. Okay, those are finished, can leave.
Thank you, Mesh.